Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today we'll be talking about prime factorization. But first, let's identify a few vocabulary terms first before we dig into the math, right? So first off, let's talk about prime numbers. Prime numbers are numbers such as, let me get my color. Here we go. All right. Prime numbers are numbers like 2, 3, 7, 23, 97. All right. Numbers like this are called prime numbers, ladies and gentlemen, because only 1 times that value will give you the number. In other words, the only factors for each of these numbers is 1 times itself. So for instance, if I'm looking at a number like 13, if I were to list all the factors of 13, it would only be 1 times 13. That's it. Yeah. If I was listing the factors of, let's say, a number like 29, it would only be 1 times 29. So prime numbers only have 2 factors. That's it. So, when we speak of composite numbers have more than just 2 factors. So, for instance, if I'm looking at a number like 30, well, the factors of 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. So, notice that this particular value, 30, has several factors. It has 1, 2, 3, 4, 5, 6, 7, 8 factors. So this is an example of a composite number. It has more than just 1 times itself that will give you 30. All right, so more factors than just 2. More examples of that would be a number like 40, 1,000, 12, 24. All of these numbers here are composite numbers because they have more than just 2 factors. There's more than just 1 and another number as a factor. You got it. Those are composite numbers. Then the number 1 is neither prime nor is it composite. The reason for this is that prime numbers must have one number times another number in order to be a prime number. You can't say that about the number 1 because 1 times 1 is 1. So you can't ever say that 1 times another number will give you 1. Therefore, 1 is an exception. 1 is neither prime nor is a composite. Well, I said all that, ladies and gentlemen, because what I want to do is find the prime factorizations. But before we did that, we had to make sure that you knew what a prime number was, right? So there you go. Prime numbers only have 2 factors, 1 and another number. That's it. Let's look at how to go about finding some prime numbers. When it comes to finding the prime factorization, I'm going to show you 2 ways to do each of these problems, all right? So there may be other ways to find the prime factorization, but these are the ways that I know and teach all the time, okay? So the first one is my favorite. It's the factor tree. You can call it the Christmas tree method. I do sometimes, but that's the one that is most popular for me, all right? Love the factor tree. That's how I roll, okay? So if you're keeping up with the way Mr. Witt does things, this is how I do it. Problem number 1, I have 12. So first of all, you want to think of 2 numbers, not including 1, that'll multiply to give us 12. Well, I know that 2 times 6 will give me 12. And since 2 is a prime number, you're just going to bring that down. So anytime you get a factor here that's a prime number, just bring it on down, branch out from there. Well, 6 is a composite number. You can find 2 numbers other than 1 times 6 that'll give you 6, right? What 2 numbers will multiply to give you 6? Great. Absolutely right. 2 times 3. So once I have it in this format, these are my prime numbers. Notice that I don't have any composite numbers left. So 2 times 2 times is going to be the prime factorization of 12. And I can even simplify that and say that this is going to be 2 to the 2nd power times 3. All right, that's my answer. That's it. 2 squared times 3. That's the prime factorization of 12. Beautiful. Okay, well, how about that other method, right? Let me show you this. Well, when you're using the other method, you have to first of all already be aware of at least one of the prime factors for this number. Well, divisibility comes in handy. For instance, I know that 12 can be divided by 2 because it's an even number. Yeah, so any number that ends in 0, 2, 4, 6, and 8 can be divided by 2 every time. Another factor that's a prime factor that I know that can go evenly into 12 is the number 3. Well, how can you tell that? Because if you add the digits 1 plus 2, 1 plus 2 is 3. Any number that adds to 3 and a multiple of 3 can be divided by 3. So it's important to know those divisibility rules because they come in handy. Can I tell you? Handy. All right, so this is going to be the second way that we could do this. Let's start out with the fact that 12 can be divided by 3. So once again, you're going to be dividing each time by a prime number. That's the way you do this second method I'm going to show you. And we're going to use like an upside down division symbol on this, so don't freak out when you see it, right? All right, so I'm going to put 3 on the outside of this upside down division symbol. I'm going to put my 12 right in there, okay? Nice and snug. 3 goes into 12 how many times? Well, very good. 4 times. So then I'm going to branch out again. And I'm always going to divide by a prime number. So a prime number that will go evenly into 4, you guessed it, it's 2. And that'll leave me with 2. So notice on this outside here, all right, on this outside, on the exterior, we have 3 times 2 times 2. So these numbers right here on the outside, those are my prime numbers. That's the prime factorization. That's what I was looking for. So 2 times 2 times 3 right there. And once again, I can go ahead and write it as 2 squared times 3. Let me go ahead and box that up. Nice big red box for you. Bam. That's it. Yeah. So we'll have the factor tree method there. That's my preferred method. And we also have this method right here with the upside down division. Yeah, we'll just call it that. I'm sure it has a nice proper name, but I don't know it. So I'm going to call it upside down division. All right, we're just going to go with that. All right, so that's how you do it. Those are the 2 methods I wanted to show you. So let's go ahead and put this into practice. Okay, let's find out some more, right? So here in our next example, we have 36. Once again, I'm going to go with the factor tree because that's my preferred method. All right, so 2 numbers that I multiply to give you 36. I'm going to go with... I'm going to go with 3 times 12. There you go. So 3 times 12. 3 is a prime number, so I'm going to bring that down. I can break up 12 into, let's use 3 times 4. Okay, there you go. And then I'm bringing down my 3, and the 4 will break up into 2 times 2. So there you have it. Those are all the prime numbers. You stop when you have nothing left but prime numbers. So when this row contains only prime numbers, you're done. So the prime factorization of 36 is 2 times 2 times 3 times 3. Notice how I write them in ascending order. It helps me keep up with all my factors if I write it in ascending order, and it also makes it easier to write it in exponential notation, okay? So here I can easily see that I have 2 to the second power times 3 to the second power, and that's it. All right, I'm red boxing it. That's it. All right, let's look at that upside down division way. All right, so let's check that out. Now, once again, when you're using this second strategy, you're going to have to divide by a known prime number. So what do I know about 36? Well, I know it can be divided by 2. It's an even number. I know it can be divided by 3 because 3 plus 6 is 9, and 9 can be divided by 3. So therefore, 3 goes into that number evenly. This time, let's go ahead and crack things open by starting with 2. There you go. I'm going to start with 2. 2 goes into 36. That's going to leave me with 18. All right, getting that 8 together. And then a prime number that'll go evenly into 18. Yeah, I'm going to go with 2 again. That'll leave me with 9. A prime number that'll go into 9. 3. That leaves me with 3. Done. You know what? I'm starting to like this. I'm starting to like this method. I don't know. I've always hated this method, but for some reason today this method is kind of feeling kind of cool to me. I don't know why. But that's an ugly 3. We're not gonna let that slide, are we? No. You won't let me. You knew it was ugly. You know it couldn't stay, so it had to go. You're right. Okay, this 3 is not that much better, but I'm gonna keep it that way. All right. So anyway, I'm moving on. Dang. All right. Always worried about my 3s. So here I'm gonna write this as 2 squared times 3 squared, and that's the answer. That's it. That's it. Done and done. All right. Well, there you go. Upside down division as well as Christmas tree. Okay, so here we're going to start with the third problem. 144. Well, what do I know about 144? Okay, 2 numbers that I'll multiply there. I'm going to go with 12 times 12 because it's a perfect square, and I know that. All right, so if you didn't know that, what would happen if you would add all the numbers together? Let's see, if you add 1 plus 4 plus 4, what does that equal to? Exactly, it equals to 9. Did you know that any number whose digits add to 9 or a multiple of 9 can be divided by 9? Well, it's true. Yeah, check out the multiples of 9. Add them up. If the sum is 9 or a multiple of 9, it can be divided by 9. Yeah, so this adds to 9, so it can be divided by 9. Matter of fact, I'm going to use 9. I'm going to say 9 times 16 because that multiplies to give me 144. You could have said 12 times 12. I know, but I'm going to use 9 times 16. So 9 breaks up into 3 times 3. And 16 I'll use 4 times 4. So I bring down the 3, and these 4s will break up into 2 times 2 times 2 times 2, okay? So I'm left with nothing but prime numbers, so I'm done. All right, so writing this in ascending order, I'm going to have 2 times 2 times 2 times 2 times 3 times 3, or we can simplify this in exponential notation by saying that this is 2 to the 4th power times 3 squared, and this is going to be my answer. Here comes your red box. There it is. That's how you know it's done, because I just red boxed it. Okay, that's the prime factorization of 144. Okay, now let's see what happens if I use that second strategy. All right, so let's go ahead and change my pen color to black, and let's start off by, what do you want to divide by? Let's divide by 2. Let's divide by 2. I'm going to say 2 going into 144. Well, 2 goes into 144 is 72 times. And let's go 2 going into 72, that'll be 36 times. And let's say that 2 goes into 36, that'll be 18 times. And let's say that 2 goes into 18, that's going to be 9 times. And I'm going to say 3 goes into 9 3 times. There you go. All right, so that's everything. Once again, I'm starting not to hate this method so much. It's not that bad. All right, so here I have 2 times 2 times 2 times 2. I have 4 2's that are all multiplying, and I have 2 3's. And simplifying this, I can rewrite it as 2 to the 4th power times 3 to the 2nd power. That's not bad. That second method is really not that bad. I don't know why I've hated you so much all these years. I think I'm going to start liking you a bit more. I may call on you to do more problems for me in the future. Just saying. Okay? All right. Here we go. Problem number 4. This problem, we have 56, right? So if I'm going to use the factor tree, I'm going to break this down. I know it can be divided by 2. So this is going to be 2 times 28. Yeah. Bring down this 2, and I'm going to break this down to 4 times 7. And then from there, I'm going to say that I have 2. This 4 breaks up into 2 times 2. I'm going to bring down this 7. And these are all prime numbers that are left over. That means I'm done. So 2 times 2 times 2 times 7 is going to be the prime factorization. I know that these are ugly 2's. I know that they're ugly 2's, but I'm not going to force you. You're not going to force me to rewrite. Okay, fine. I'll rewrite them. Wow. 2 times 2 times 7. Okay, I was in a rush. I'm sorry about the ugly 2's. So now if I rewrite this in exponential notation, it will be 2 to the 3rd power. And there's my answer. That's it. You got it. 2 to the 3rd power times 7. Done. Yeah. Let me show you that other method now, that upside down division method. And being as though I do recognize that this is a even number, it's an even number. It ends in 6. That guarantees that the prime number 2 can go evenly into 56. So let's go ahead and start out with that. So we'll say 2 goes into 56. Then 2 goes into 56, that's 28 times. And then I can say 2 goes into 28, 14 times. And then I can say 2 goes into 14, 7 times. And that's it. Why is this starting to appeal to me? All right. Guys, let me know what you think about this second method here, because I'm thinking the more I do it, it's starting to feel faster than the factor tree, which, has been my true love for years and years. So I'm thinking I'm thinking about cheating on the factor tree. I'm thinking I may give in and start using this method more often. Okay. All right. So there you go. Yeah. We divided by 2, then divided by 2, then divided by 2, and that left us with 7. And so that's our prime factorization for 56. I boxed it up after I wrote it as an exponent. I boxed it up. I boxed it up after I simplified it and wrote it in exponential notation. So that was problem number 4, and I have more to show you, so let's get to it. All right, next problem here is 51. Yeah. Oh, you say 51 is a prime number because it looks ugly? Well, you're right about it being ugly, but it's not a prime number. No, you can actually factor this. Well, how do you know? Well, let me show you something. If you add 5 plus 1 together, what does that give you? Exactly. It gives you 6, which means that any number whose sum is a multiple of 3, it can be divided by 3. So, ladies and gentlemen, 51, the prime numbers are 3 and 17. Yeah. 3 times 17 is 51. Go ahead and multiply that out, verify it for me. All right, there you go. So, therefore, the prime factorization of 51, 3 times 17. That's it. That's all there. That's it. That's all there is to it. Let me go ahead and get my red box for you. There you go. There it is. There it is. Red box in it. That's it. So, upside down division. Here I have 51, and once again, using divisibility, I realize that 5 plus 1 is 6, so therefore it can be divided by 3. Yeah. I'm going to say that 3 goes into 51, all right, 17 times. Well, there you go. That's the prime factorization. I'm done. I can't go any further. 17 is a prime number. So that is going to be written in ascending order like so. 3 times 17. That's it. Done. Okay. Next problem. Here we have 6. And with 6, we're looking at finding the prime factorization for 78. Yeah, so with 78, I'm going to use my factor tree. One thing I know about this is that it can be divided by 2. It can also be divided by 3 because 7 plus 8 is 15. Did you see that 3 in there? Yeah. Okay, so therefore, I'm going to break this down. I'm just going to go by 2. I'm going to just say 2 times 39. Oh, I hate it. I hate it. All right, much better. 2 times 39. Bring down the 2. Your 39 can be broken up into 3 times 13. Okay? There's your prime factorization right there. So 78, its prime factorization is 2 times 3 times 13. Red box in it. Done. That's the prime factorization for 78. Okay? Going with our upside down division here, let's check out the following. Let's change my pen color here. All right, I'm going to say that I'm going to go with 2 again because 2's easy to take half of a number. All right, so 2 goes into 78. That's going to be 39 times. And then, yeah, I know it can be divided by 3. So 3 goes into 39, 13 times. And there you go. There's your prime factorization, upside down division method. Okay, let's go ahead and write that out. So 2 times 3 times 13. And I'm going to red box it. That's it. Wonderful. Let's keep this thing moving. Keep this thing moving. See, I wanted to give you a lot of examples, so there you have it. I want to give you a lot of examples. Let's look at problem number 7. If I'm looking at the factor tree for problem number 7, you know what's standing out to me right now? I'm going to go with 12 times 10. I needed 2 numbers that are multiplied to give me 120, and this number ends in 0, so it can be divided by 10. So 12 times 10 gives me 120. Then from there, I can break down this 12 into 2 times 6. I can break down the 10 into 2 times 5. 2 is a prime number, so bring it down. I can break down 6 into 2 times 3. 2 is a prime number, and 5 is a prime number. So my prime factorization, if I write these in ascending order here, all right, this is going to be 2 times 2 times 2 times 3 times 5. All right, and then writing this in exponential notation, I'll have 2 to the 3rd power times 3 times 5, and that's the answer. That's it. All right, great. Problem number 7. Once again, upside down division method, okay? So what I'm looking at here is the fact that if I have 120 and I'm looking for a prime number that'll go in there, I'm going to divide by 2. So when I'm doing this method, I like the number 2. It's just easier. So 2 goes into 120 60 times. 2 goes into 60 30 times. 2 goes into 30 15 times. 3 goes into 15 5 times. So it's something about this method that compels me to start with the smallest prime numbers and then work my way up. Whereas with the factor tree, I just randomly pick numbers to use. But this method, it kind of compels, it kind of forces me in a sense. I feel obligated to start with a smaller number and then work my way up. It's just the way it works out every time for me. But one way or another, I'm starting to like this method better. So this gives me 2 times 2 times 2 times 3 times 5. I don't know why I used to hate this method so much. I used to despise this method. Sometimes I wouldn't even teach it to my class because I felt it sucked, but doing this with you guys today, I'm really starting to like this method. It's like the more I use it, the more I like it. All right, so here we go. Last problem. Problem number 8, we have the number 300. Okay, great. Yes, it was a movie, but it's a problem. So with 300, we're going to find the prime factorization of it. And two numbers that I'll use, I'm going to use 30 and 10. There you go. So these two numbers will multiply to give me 300. So you can use your own knowledge base to figure out what numbers you want to use. You could have used 3 times 100. You could have used, 50 times 6. It's different factors out there that you could have used, but I chose 30 times 10. So then I will be breaking down this 30 into 5 times 6, breaking down the 10 into 2 times 5, and then I'll bring down this 5. I'm going to break up the 6 into 2 times 3. This will be a 2 coming down and a 5 coming down. So that's my prime factorization right there. And writing this in ascending order, I'll have 2 times 2 times 3 times 5 times 5. All right? All right, writing this in exponential notation, you'll have 2 to the second power times 3 times 5 to the second power. And this is going to be my result here. That's it. Done and done. Yeah. All right, upside down division method. Let's check that out. For this 300 here, I know it can be divided by 2, so I'm going to use that. All right, so let's divide this 300 by 2. I'll start telling you I like the smaller numbers, so I'm going to go with that. 2 goes into 300 150 times. Yeah, and if you didn't know that, then you could always use long division. 2 goes into 150 75 times. Yep. And then we're going to go with 3 goes into 75 25 times. And then finally, 5 goes into 25 5 times. So there it is. The prime factorization. So this is going to equal to 2 times 2 times 3 times 5 times 5. And once again, in exponential notation, I'll have 2 squared times 3 times 5 squared. I'm really happy about this 2 right here because it looks kind of cute, because normally my 2's are jacked up. So for some reason I like this 2 right here, that exponent 2. It's really making me happy. Okay, hey, ladies and gentlemen, there's your prime factorization. All right, so this is Mr. Witt. This was prime factorization. Hope you liked it. As always, please rate, comment, and subscribe. And if you want more free videos, ladies and gentlemen, if you are able, go ahead and donate. And once again, peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.